Hey gang, welcome back. It's the last section in this chapter, and we're going to talk today about dot product for vectors, okay? We've talked about adding vectors. We talked about how to write vectors in IJK form, right? By using the three methods, lambda hat, directional cosines, and what was the other one? Blue triangles, or you might have known it as spherical coordinates, right? That's the three ways I can give you vectors. But they ask us every once in a while a weird question, right? Sometimes they might ask you a thing like, hey, what's the angle between two vectors? Well, like if I have, here's one blue vector, there's a blue vector, right? And they're 3D vectors, so they can be in any orientation. What's the angle between those two vectors? Why would you ever want to know that? You know, sometimes you just need to know that. So how do you find that? With a little trick, a little mathematical trick that we call dot product. We're gonna solve it over there in just a second. But this is the equation that this is a new equation for today. If to find theta is this angle between the two vectors, right? So the cosine of that angle is the first vector, we'll call it vector A, dotted with vector B, and we'll go over how to do dot product here in just a second, divided by the magnitude of vector A times the magnitude of vector B. This is not dotted. This is just regular old multiplication, okay? Take the inverse cosine of that and bam, you got theta, the angle between those two vectors. The next question that they might ask you is really wacky here. What is the magnitude of the projection of a force on a line? What is projection? What is that? Do we remember what that is? This is a vocabulary thing that might trick you on a test, okay? If they ask you about projection, okay, well, projection is just a shadow, right? We did this before. Remember earlier in the lessons where we had like the statics flashlight shining on the vector and it made a projection onto the axis, and we also called that a component, okay? So all they're asking you here is, if you had a component that was along some other line, some other, point A to point B, what would that projection look like, okay? Like for instance, here over this one, we're going to find the magnitude of F2. Here's F2 that is projected onto F1. So if I made a shadow of F2 onto F1, how big would that component or that projection be, okay? And we can do that with this right here. The magnitude of that projection. This is the projection. This is the component right here, okay? I just called it F line. That's the part of, normally we would call it like Fx or Fy, but in this case it's F line, right? Why is it F line? Because it's not on one of the coordinate axes. It's not the component on the X, the Y, or the Z. It's the component on a wacky axis, right? Some other axis, some other line, okay? And how do we find that? We dot the force vector, right? The one that is doing the projecting. This is the main vector that is doing the projecting, dotted with lambda hat. We know how to find lambda hat, don't we? Of the line that we're projecting onto, okay? So let's see if we can do these two things. Now, this is not my favorite thing in statics. Matter of fact, it's my least favorite thing. Why? We do it now, it's likely that you'll probably never ever see this again in the course. But we got to do it. So here, let's go learn how to do it right quick, okay? All right, so here we go. We got two parts, part A, part B. Part A says, find the angle between F1 and F2. Well, in order to do that, I need to know what is the vector F1, what is the vector F2. We're going to practice a little bit of the things that we have learned in the past lessons. Here we go. Let's start with F1. What is F1? Is it blue triangle? Is it directional cosine? Or is it lambda hat with coordinates? It's lambda hat, isn't it? Okay, so let's see if we can write this guy. Okay, so this vector goes from the origin to this point over here. So first off, I've got to write my position vector. How do I get from here to here? That's how you get to grandma's house, right? And I go what? Let's see. I go -2 in the I hat direction, right? -2 that way. And then I go 3 in the negative y, so -3j hat. And then I go whoop, uphill plus 4k hat. That's how you get from there to there. Now we take that and divide it by what? its magnitude, 2 squared plus 3 squared plus 4 squared. 16 and 9 is 25, and 4 more is, I don't know, 29. Okay. 5.385. Okay, so lambda hat for that vector, let's call it F1, right? Lambda hat for F1 is going to be equal to negative point what? Let's see, 2 divided by answer equals 0.371. Okay, minus 3 divided by that, 3 divided by 5.385 equals 0.557. 557 j hat. One more, plus 4 divided by 5.385 equals 0.743 k hat. Okay, so there is my lambda vector. Okay, that's pretty handy. I'll need that here in a minute, right? And then, so for writing F1 in IJK form, right? F1 is equal to what? Do you remember? It's F, right? Vector F1 is F times lambda hat, right? How big is F? What's the magnitude of F1? 125. So I'm going to multiply 125 times that, right? And I'm going to get a vector here. So let's see what we get. 0.371 times 125 is 46.38. Okay, and that's negative, isn't it? So it's going to be negative, negative, positive, minus 125 times 0.557 equals 69.63. And then what? Plus 0.743 times 125 equals 92.88. Okay, so there's vector F1 in IJK form. Now we got to do vector F2. How is vector F2 given? Ooh, this is tricky. Look at that. Oh, this one's going to be bad, isn't it, y'all? This is good review here, okay? F2 is written with directional cosines, okay? So what do they give me? For F2, they give me theta x, right? Right? Because theta x is the angle between the positive x and the vector. It's 120. Now, theta y is given, but it's a trap. Don't fall for it, okay? It's a trap! Who said that? Okay, let's see if you can go. Tell me in the comments who said that. Okay, here we go. Theta y. Theta y, look what they give me. From the y-axis over to the vector is 130. But let's see, theta y is from... Ooh, it's from positive y, isn't it? They gave me from negative y. Oh, you tricksters. Okay, so from positive y, if it's 130 here, this must be 50, right? Because it's got to equal 180, right? So, listen, I said 180, and then I went to write 180. Oh, now I've smudged. All right, it's 50. Okay? I hope you understand that. From positive y is 50 because from negative y is 130. And from here all the way over there is 180, right? Okay? Now what's missing? They didn't give me theta z. Theta z equals question mark. But we're smarter than the average bear. Let's see if we can find it. Do you remember the equation? The equation is this. Cosine theta x, cosine squared, plus cosine squared theta y plus cosine squared theta z equals 1, right? So we know this guy. So that would be cosine squared of 120, right? Plus cosine squared, I know that guy, 50, plus cosine squared theta z, don't know that guy, equals 1. Okay, let's see here. Let's go. Here we go. All clear. Cosine of 120 is equal to, bam, negative 0.5, and then you got to square it. What does that give you? Well, that's going to give you positive 0.25, isn't it? Okay, plus Cosine of 50, here we go. Cosine of 50 is, 0.643, and then I got to square that, equals 0.413 plus cosine squared theta z equals to 1. Let's subtract that junk off of 1. So cosine squared theta z is equal to 1 minus what? 0.413 minus 0.25 equals 0.337. Okay. Now I got to take square root of both sides. Square root of that. Square root of that, right? So that would mean that cosine theta z is equal to, what's the square root of that? Square root, answer, equals. Okay, here's where most people mess up. This is where you mess up. Don't mess up. It's this. Plus minus, right? 0.581. Okay? Why do I have to have the plus minus? Because if I take the inverse cosine of a negative number, I get an angle bigger than 90. I take an inverse cosine of a positive number, I get an angle smaller than 90, okay? And then I got to choose which one is the correct one. So let's see what we get here. So inverse cosine of answer is equal to 54.5. So the positive root gives you 54.5 degrees. What does the negative root give you? Let's see. Negative, clear. Negative 0.581, right? And then inverse cosine of that is 125.5. Okay? Now, I have to choose which one of those two is the real FZ. What do you think? Okay? Which one is the real FZ? Is it 54 degrees or is it 125 degrees? Since this vector is in this top quadrant here, this upper quadrant, I would choose the 54.5 degrees. If it was the 125.5 degrees, that vector would be down here in these bottom quadrants where this positive z would be more than 90, right? So here's the other guy that we're missing right there. Theta z, 54.5 degrees. Okay, let's put him in there. Okay, now that we have theta z, we can use our directional cosine equations to write vector f2 just like we wrote vector f1 here. Okay, so we recall our directional cosine equations. Fx is equal to f cosine theta x. Fy is equal to f cosine theta y. Fz is equal to f cosine theta z. Okay? So, what is fx? Fx is what? F is 210. 210 cos theta x, which is 120. What are you expecting for that? A negative, right? The cosine is bigger than 90 degrees, is going to give me a negative number, right? The next one, 210 cosine theta y, 50 degrees, positive answer. Theta z, 210 cosine 54.5, positive answer. Okay, so let's get those vectors here. Here we go. Or those components, rather. 210 times the cosine of 120 is negative 105. Negative 105. Okay. And then 210 cos 50 is 135. And then 210 cos 54.5. 210 cos 54.5. 121.9. Okay? 121.9. So, vector F2 is negative, yeah, that's fine. That's fine. Negative 105 I hat, right, plus 135 j hat plus 121.9 k hat. And both of these vectors are in what? newtons, right? So that is newtons. That is newtons, okay? Can you sanity check yourself here? If you square it, square it, square it, take square root, what should you get? 125. If you square it, square it, square it, take square root, what should you get? Where'd it go? 210, right? All right, gang, so now we are ready to do the dot product. We are ready. Let's find that angle between the two vectors, right? Vector A, vector B. And in our case, it's vector F1 and vector F2, isn't it? What is dot product? Do you remember? Okay. Dot product says this. You take the apples and you multiply them together. And you take the oranges and the oranges and you multiply them together. And you take the bananas and you multiply them together, right? And then you take whatever this gives you, whatever that gives you, and whatever that gives you, and you just add those together and it equals a scalar, okay? And it is a scalar is, of course, just a magnitude. Okay? So let's see if we can do that. It's going to take our calculator, but it's super-duper easy, isn't it? And that's going to give us vector A and vector B dotted together, right? That's going to give us this top part of our equation. So it's just going to be a scalar. It's just going to be a number. So here we go. 46.38 times 105 equals, and I've got a negative times a negative, so that's going to give me a positive, right? 4870. Okay. Next, what do I have? 69.63 times 135 equals 9400. A negative times a positive gives me a negative 9400. Okay. And then what do I have? A positive times a positive. That's going to give me a positive. What's the last one? Let's see. 92.88 times 121.9 equals 11,322. 11,322. Okay? Let's add those together. So minus 9,400 plus 4,870 equals, okay, the number there. So this is F1 dotted with F2, right, is equal to, that's the top half of our equation, 6792. Okay? Let's get the bottom half. What is the bottom half? It's the magnitude of vector A times the magnitude of vector B. Okay? How do I do that? Well, the magnitude of that is just that squared plus that squared plus that squared, square root. How big is it? How big is it? Right? The second one is that squared plus that squared plus that squared, square root. How big is it? That big, right? So this down here is just 125 times 210, okay? So 125 times 210 is 26,250. Okay? So there you go. That's the dot product divided by the magnitudes. That's all of that. And that's equal to what? Cosine of that angle that we're looking for, right? We're looking for the angle between the two vectors. That's theta. Okay, let's find him. 6792 divided by answer equals 0.259. Okay, so cos theta equals 0.259. And then what? Inverse cosine of that? Inverse cos, answer equals 75 degrees. Theta equals 75 degrees. So there is 75 degrees between this angle and that, or this vector and that vector, right? There's our theta. It's here. Whoop, all the way across there. There's that theta angle, okay? 75 degrees. Dude, we did it. All right, let's do one more. Find the magnitude of the projection of F1 magnitude of F2 projected onto F1, okay? So F2 is doing the projecting, right? F1 is just a line. So F2 is going to be projected onto this, and it's going to give me like a component, right, along that guy there. So it's asking me how big is that component? from that guy, okay? Well, here's the equation for it right here. So number one, it's F. And in our case, it's going to be, who's doing the projecting? F2 is doing the projecting, right? So in our case, this is going to be F2, okay? Do we have F2? We got him. He's right there. Oh, man, that's great. Dotted with, we know how to do dot product, don't we? Lambda of the line. The line is F1. Do we know lambda hat for the line? Dude, that's right there. There's lambda hat for the line. Okay? So we need to take that guy and dot it with that guy, and we get the answer. Okay? So here's the answer. Ready? So F line, right, or the component on that line is, here we go, negative, and a negative is going to give me a positive, right? So 105 times 0.371 equals 38.96. Remember, this is going to give me a scalar. Next, I've got a negative and a positive. That's going to give me a negative, right? 135 times, what do we say, 0.557. And that is 75.2. Okay? And then what? I got a positive and a positive. That's a positive. 121.9 times 0.743 equals 90.6. Okay, and let's just add those together. 38.96 plus 90.6 minus 75.2 equals 54.36. And what is that? That's newtons, right? That is the magnitude of that projection onto this guy here. Okay? All right. That's it. That's question A answered. That's question B, right? There's question A. There's question B. Done. Okay? Let's do one more thing, okay? If you took those two vectors like that, right, and you rotated them whoop, until they were like that, okay? Right? I'm just spinning them around until this guy, this projection, right, is on this y-axis here. Right? So I'd have something that looks like this, right? Here's where I want the projection. Here's the force. I know the angle between them is 75 degrees, right? If I ask you, what is the component of that guy on this y-axis down here, right? What is this guy, right? You could do that pretty quick, couldn't you? If you knew this guy up here. Well, we know that guy. You know what he is? He's 210. Isn't this guy down here just really and truly F times the cosine of 75? Let's put that in our calculator. 210 cosine of 75 equals, what do we get? 54.35. Get the exact same answer, right? Right? This is just a different way to get that, okay? There's everything you need to know about dot product, okay? We typically use it to find the angle between two vectors or to find the projection of one vector onto another, okay? I hope that helps, and I'll see you next time.